Hmm. You know what? It's been a good start to the day. I mean, did a little exercising for a long walk. It feels nice outside. What else am I gonna do today? I'm gonna go swimming, cool down a little bit, get body back to normal, a little regulation. I feel like I'm forgetting something I'm supposed to do today. Exercise. That's right. It's time to math. See, he's laughing because he saw the Ventus video on their 52 rides, 4 parks, one day. I also laughed. Shout out Venta. That was fantastic. I loved it. And welcome back. We are here, week 2, right? We're on day 4 of some math videos. Today we're going to do a little bit of review. But before we get to the math, we got to have at least a little bit of fun. I need to have a little fun because... What are y'all doing in there? Hey! You sit down and be quiet in the back of the classroom.
Yes, sir.
Thank you. Today we're going to open some fun stuff. Like, oh, look at this right here. We've got a Disney Pixar, some type of clip, something. Figural bag clip. We can get any one of these. What are we going to get? Who knows? Let's see. Oh, dude. Squirt. Tubular. Totally. Righteous. Would you turn the phone off in class? My goodness. Can't take these people anywhere, can I? Back to the calmness. Look at that. Squirt. That's awesome. You can go up here by Max Kepler and lay down on your back. And one more. This is be kind of cool, I think. A little office grab bag. So it's going to be a character from The Office. So it's... Don't do that anymore. Oh, yes. The GOAT. Michael Scott. In the flesh. Well, in the plastic-ish shape that he's in. World's best boss. Naturally. You also can hang out with Max Kepler. It's a pretty good start to the day. All right. So let's see. We got opening stuff. Oh! Quote of the day. Of course, our demotivational quote of the day. Actually, this one's a little motivational. This is our throwback. This is from Wednesday, March 25th. Cupcakes are just muffins that believed in miracles. See, look at that. It's such a positive thought for the day, right? Let's see. Today's quote, well, I'll give you this weekend's quote as well. Look at this. Bonus quote of the day. From this weekend, it takes me 3 days to wake up in the morning. I mean, at least. Especially in COVID times. I mean, some of us are still trying to wake up from last weekend. Anyway, today's quote. Don't underestimate the extreme measures I will take to escape this conversation. Not wrong at all. Some of you have seen me do this. I'd almost apologize. All right. We've got opening stuff. Actually, we'll put the space map here next to the Halperts. Oh, Disney pins of the day, of course. Rocking my my Haunted Mansion Disney band, ready to go. Today we got little Nightmare Before Christmas-ish Mickey Mouse head. I'll take it. And one of the originals, the OG Donald Duck. I mean, gotta kick it old school every once in a while. So, opening stuff, quotes. It's time to math, obviously. Let's go. All right now. Ariel, Genie, Aladdin, carpet. Pay attention. This is going to be on the quiz. We're back. And I found my meter stick. Yes! Let me come over to the side. Today we're going to be reviewing. Why? Because, well, there's only one more lesson on ingenuity for this week that I haven't covered yet. So we're going to spread that out. We'll let that wait in summer till tomorrow. Or Wednesday. Or whenever I feel like it. One of those days, though, it will happen. Today we're going to do review day, solving an equation. Why? Because you need to be able to solve an equation, especially in algebra, where the goal is always to solve for the variable, right? We're trying to find that logical way to get to an answer. So today we're going to work with this equation. 3/2 b plus 5/4 equals 1/3 times the quantity 2b minus 5. Wait a second. I see a problem in this equation. Well, it's not a problem, but most of you might think it's a problem because you've all told me you hate the F word. You hate the F word. Fractions, of course. So, when we're solving an equation, what do we do first? We get rid of the fractions. How do we do that? Well, let's look at our denominators. I've got 2, 4, and 3. So I need to find the least common multiple of my denominators so that I can multiply both sides of the equation by the same number to eliminate all the fractions. So I think 2, 4, and 3. Well, 4 times 3 is 12, and 2 is 12 is also a number is a multiple of 2. Let's try that. I'm going to multiply both sides of this equation by 2. So we do that. All right, 12, excuse me, not 2. That would have been bad, and we would have not gotten rid of our fractions. So 12 times 3 halves b, it gives me 36 halves times b, plus 12 times 5 fourths, which is going to be 60 over 4. Now, what property did we just use here? I'll wait for your answers. No, not the associative property. No, not a property tax from Monopoly. That's just ridiculous. There are stupid questions. That was one of them. We used the old distributive property, of course, to distribute 12 to both terms inside the parentheses. Over on the other side of our equation here, let's go ahead and multiply 12 times 1/3 to get 12 thirds times 2b minus 5, where we don't have to multiply 12 times to the parentheses because we're already using multiplication here. Just rearranging the order of our numbers. Now we can simplify our fractions and get rid of some stuff here. So let's look. 36 divided by 2. 3 one time. 1, that's 18b plus 15 equals 4 times 2b minus 5. This marker is done. Next marker, which means we got another step to work on. Our next action, the next thing we want to do, is we want to simplify each side of the equation. The left side here is already simplified, so that's good. 18b plus 15, they're not like terms, so we can't add them together. But on the right side, I can come back to that favorite property of mine. We just used it up here. The old distributive property. Again, thank you, Mr. Carter. Still in my head from when I was an 8th grader. We're going to distribute. And we have 18b plus 15 equals 8b minus 20. We've simplified both sides. It's time to get a new marker. No, we're going to save blue one. I'm going to save blue one for later. We'll get orange right now. So again, our second step, we get a marker real quick. What did we do? Simplify, of course. Now we can go. Our third step. What's the goal? What's our goal in solving this equation? We're trying to find our unknown. We're trying to find the value of our variable. So we're going to get the variable. To only one side of the equation. How do we do that? Well, we've got to decide, do I want to get rid of 18b from the left side? Get rid of 8b from the right side of the equal sign. I'm going to get rid of that 8b from the right side because I like positive numbers when given the choice. And by doing this, 18b minus 8b is 10b plus 15 equals negative 20. Because that canceled out. Our variable is only on one side. We only got 2 more steps really to go here. We come to step 4, which is, again, this is one of my favorite steps in this. Why? Because I get to write a word that's a little silly and a little ridiculous. We've gotten the variable to one side. That's great, but there's something over here still stopping us from being able to fully find out this variable. So our next step is to get everything. That's right, get everything. To the other side of the equation. What does that mean? Well, I got adding 15 here. Let's get rid of that. How do I cancel out a positive 15 or plus 15 from this side? I want that to be plus 0. We're going to have to do our opposite here. We're going to subtract 15. 10b plus 0, which 10b equals negative 20 minus 15. We're subtracting a negative from a negative here, getting more negative. It's going to be negative 35. One marker left. Means we got one more step here. We know what 10b equals, but do I care what 10b equals? Of course not. I don't care about 10b. I want to know what 1b equals. So at this point, we've got to divide by the variable's coefficient. Divide both sides. The coefficient of b is 10. If I divide the left side of the equation by 10, that cancels out. I end up with 1b. If I do something to one side of the equation, I have to do it to the other side to keep everything balanced. Now, the other part we have to do is simplify here, because negative 35 over 10 is a correct answer. But if we're asked to simplify that fraction, we need to be able to recognize common multiple, or common factor here. For 35 and 10, I think, what's the greatest common factor? It would be 5. 35 divided by 5 is 7. 10 divided by 5 is 2. It's a negative number, so b equals negative 7 halves. Again, get rid of the fractions. We simplify. Get the variable to only one side. Get everything else to the other side. Divide by the variable's coefficient. Simplify if we have to. We can solve an equation. Even with dreaded fractions, we're able to solve it going step by step. Be right back with one more equation we're going to solve, and then we'll be done for the day. Once again, look, 4 days of making these videos, and for the 4th day in a row, the family is coming to watch the son of the teacher of the universe teach us some algebra. Anthony, Ross, Rebecca, Nelson, Elmo, thanks for being here, guys. I appreciate it. Here we are, back for our second part of the lesson. We're going to look at solving an equation. Literally. We're literally going to solve the equation, but we're going to solve a literal equation, which only means we might have some more variables in there. We're just solving for a specific variable. Equations don't always have to have numbers that we can recognize to be able to solve. For example, q equals 1/2 p plus 15. It's an equation. There's an equal sign. There's things on both sides of the terms on both sides. If we want to solve this equation for p, all we have to do is rewrite this equation in an equivalent form, but we want to have p by itself. So if I'm going to solve this out, what was that, Chef Mickey? That's right. We're going to subtract 15 first. Our goal is to get p by itself. Well, let's start by getting rid of that 15. Now, that could cancel out, but q minus 15, they're not like terms, so I can't combine them into one term. We're going to have to leave it. That's just q minus 15. That phone is going off again. I'm going to lose my mind. Not really, just kidding. Equals 1/2 p. A private caller, that's not known. As you know, if we were in class, I'd try to answer the phone and talk to a telemarketer right now, but we're not in class. Q minus 15 equals 1/2 p. Now all we gotta do is get p by itself. We're trying to get p isolated. We're solving for p. Well, if I know what half of p equals, we can find out what a whole p equals by multiplying both sides by 2. 2 times 1/2 equals, see, Remy knew. Chef Remy knew. 1. So we know that we have p on the right side of the equation. Perfect. Over on the left side, we can use our distributive property. 4, that being stuck in my brain forever. 2q minus 30 equals p. Fantastic. Come over here. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You might recognize this formula here. It's our formula for finding the slope of a line if we know 2 points on the line. But say we're not trying to solve for slope. In this case, I'm trying to find out y sub 1. I'm trying to find the y value of one of the points. Well, we're going to get y1 by itself. Let's look over here. I got a fraction. We don't like fractions, right? Who likes fractions? One of you likes fractions? Well, great. You are the exception to the rule. Everybody else hates them for whatever reason. I don't mind them. They're just numbers. In this case, if I multiply both sides of this equation by x2 minus x1, that m times x2 minus x1 equals, that just canceled out, y2 minus y1. Well, let's see what else we need to do here. We're trying to solve for y sub 1. Let's get rid of that y sub 2. How do we do that? Subtract. That can cancel out. Gotta keep the sign from y sub 1 here. On this side, I don't have any like terms to add or subtract, so I'm just going to leave it as m times x2 minus x1 minus y sub 2. And we're done, right? Wait. We're not done. Why are we not done? Oh, that's right. Do I care about negative y sub 1? I don't. Not even at all. How can we turn this negative y sub 1 into positive y sub 1? Chef Minnie, what was that? No, we're not going to add anything. Try again. What do you think? That's right. We can multiply or divide by negative 1. We know a negative number times a negative number becomes positive. Over here, negative m times x2 minus x1. Negative 1 times negative y sub 2 becomes plus y sub 2. We got to use, guys, just because we can. It was that distributive property coming into play again so many times. So useful. And we get y sub 1 equals negative m times x sub 2 minus x sub 1 plus y sub 2. We solve the equation for y sub 1. We're using the same math properties that we used in our equation earlier with all the numbers that we could see. Applying the same principles, just not able to combine terms because we don't have like terms. But the process really didn't change, did it? Awesome. Now, just for all of you at home who can't play mum ball like we all want to, got a ball right here. I'm going to pass the ball to you. If you drop it, though, you lose and I win. Just be aware. See? The winner and still champion, Mr. Jerkins. Like 4 days down. We're going to survive through all of this stuff. Don't worry about it. We're going to keep coming back with more math videos every day. Tomorrow, more likely to get a little bit with vertex form and our quadratic equations, and then some more review afterwards. Come back tomorrow. We'll see you here. Looking forward to it.